Hello, and welcome to 5-Minute Math. Today we are looking at the fourth grade concept of classifying two-dimensional shapes. This is 4.60 Readiness Practice, the advanced version. If you are interested in exploring the 4.60 Readiness Practice resources for the intermediate or proficient versions, or the Readiness Practice resources aligned with any other standard, you can find those by using the link in the video description. So first we need to draw and name two different shapes that have at least one set of perpendicular sides. So those are sides that form right angles like this. It's represented by uh, what looks like an upside down capital T and one acute angle. So it's an angle that is less than 90 degrees. Right? So if we wanted to start like this, we can start with a right angle, and then we can start with an acute angle. And we can say to ourselves, what could we make with that? Well, it can be any shape here, and watch what happens if I do this. If I extend this up here, and I make that a triangle, what I have is a right triangle, and it has two acute angles and one set of perpendicular lines which make a right angle. So we can make a right triangle. We can also make a, see if I can get that straight up and down, we can make a right trapezoid. Watch this. I'm going to kind of extend it like this. So it's not a regular trapezoid that we think of a lot, but we've got perpendicular lines right there. And we do have an acute angle right there. So this is a trapezoid because it is a quadrilateral that only has one set of parallel lines, but it has a right angle. So we'll call this a right trapezoid. Right, so these are two options. You might be able to think of another, but these are the first two that come to my mind. So we've got 6 figures here, and we need to do a whole bunch with them. We need to find parallel sides. We need to find perpendicular sides. So at least one pair of parallel sides, at least one pair of perpendicular sides, one obtuse angle. So that is an angle that is greater than 90 degrees. So we'll kind of show it like this. And then one acute angle. So that is less than 90 degrees. So we'll kind of show it like this. All right, so let's go ahead and name these. This is a triangle, but this is an equilateral triangle. That means it's got all sides and all angles equal. This is a square. That's pretty simple. This is a rectangle. Here is our right trapezoid that we just saw in our previous problem. This is a 1, 2, 3, 4, 5. This is a 5-sided shape. This is a pentagon, but all sides are equal. So call this a regular pentagon. And that's what happens when you get all sides and all angles equal. You put that word regular up in front. Then we have an arrow. Arrow is not a shape. Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this is a 9-sided shape, which looks like an arrow, but a 9-sided shape actually has a name. It is a nonagon. N-O-N, and then agon. All right, so let's put these together here, and let's think. Parallel lines. Equilateral triangle doesn't have any. Square. Okay, so square has got one pair of parallel sides. So is the rectangle. The right trapezoid only has one pair of parallel lines. The regular pentagon does not, and the nonagon does. So let's put that in there, nonagon. Let's just draw those parallel lines. At least one pair would be right there. These are lines that never intersect if you extend them forever, same distance apart. Okay, so now let's look at our perpendicular lines. So I see my perpendicular lines here in my square, a rectangle, a right trapezoid, and my nonagon. They form a right angle. So it looks like we are going to repeat these same shapes down on that second row. Square, rectangle, right trapezoid, and then my nonagon. Now, an obtuse angle. All right, so an obtuse angle is an angle that is larger than 90 degrees. No for equilateral triangle, no for square, no for rectangle. I do have one right here on my right trapezoid. And then all of my angles on my regular pentagon are obtuse. Because if you think about a right angle being up and down like this, the angle in the regular pentagon is just slightly larger than that. And then it's hard to say on this angle right here inside the nonagon, but that looks like it's going to be a right angle. So it looks like this is just a series of right angles. Now we do have this large uh, large angle that is greater than 180 degrees. We're not going to count that because it needs to be between 90 degrees and 180 degrees, a straight line. So no for the nonagon. So we are just going to have two. Right trapezoid, and then our regular pentagon. And then finally, we are looking at our acute angles. These are angles that are less than 90 degrees. And let's see, so we can finally get our equilateral triangle into the game. No for square and rectangle, they're just right angles. We do have one for our right trapezoid, and no for regular pentagon. And then same thing, nonagon looks like a series of right angles, except for those really large angles greater than 180 degrees. So we are going to list our equilateral triangle, and we are also going to list our right trapezoid, and that's it. So that's how we would classify these shapes based on parallel perpendicular lines and the presence of certain angles. Now we need to draw certain things. So let's just go ahead and label these 1, 2, 3, 4, 5. And let's draw what they want us to draw. A triangle with perpendicular lines and two congruent sides. So we need perpendicular lines like this. So I'm just going to make my right angle like this. And two congruent sides means these two sides need to have the exact same length. So we're going to make a right angle like this. And so what we have is a certain triangle. It is a right, but it's an isosceles triangle. That's what the isosceles shows, that it's got two side lengths that are equal. So right isosceles triangle. That's how we would label our first shape. For our second shape, triangle with three acute angles. Okay, so we can draw an equilateral triangle, though it doesn't have to be necessarily an equilateral triangle. We'll just draw an acute triangle because you can make it to where each side length is not necessarily the same. So this will make this an acute triangle. 3, a quadrilateral with one pair of parallel lines and a right angle. All right, so that is our right trapezoid that we've been drawing. I'll draw it kind of like this so we can see it rotated a little bit. So we've got that one pair of parallel lines, and we also have the right angles. We have two right angles, and that's fine as long as we have uh, a right angle. 2 is fine. So we've got our 1, 2, and 3. Let's do 4 and 5. Quadrilateral, two pairs of parallel lines. Okay, that's going to be a parallelogram. 4 congruent sides. Okay, no right angles. All right, so this is going to be a rhombus. Okay, so think of it like a diamond. If we're thinking of the uh, shapes that we have on pattern blocks, this would be either the blue or the tan. They're both rhombuses. It's like a square, equal sides, except it's squished so that it's not four right angles. Now we have 5, a quadrilateral with two pairs of parallel lines, so it's another parallelogram. two obtuse angles, and two acute angles. So this is just going to be what we would consider a parallelogram like this. See if we can get that drawn there. And so see if we can make that a little bit better. But what we're looking for here is we are looking for two side lengths that are equal. There we go. And we're just going to call this a parallelogram because it's got the two acute angles, the two obtuse angles, and then it's got opposite sides that are parallel. So if you're interested in exploring the 4.60 readiness practice resources aligned with the intermediate or proficient versions, or the readiness practice resources aligned with any other standard, you can find those by using the link in the video description.